Uh, can you all hear me?
Yes, sir.
Right, thanks. All right, so during the work session, we talked a little bit uh, about dictionaries and how to use them, and then we ended by talking about how to have functions return lists. So I wanna focus a little bit more about how to make functions return things which can be reused. But before that, let's talk about how to actually create lists and dictionaries. All right, so and by the way, if you wanna follow along, copy paste I'm using the same sheet which we used last time. The link is in the chat. All right. Yeah, so let's talk about lists first. And so creating a list is done by using square brackets. So an empty list would be this, just square brackets with nothing inside of it, and initializing it with values would be, some values inside of square brackets separated by commas. And once a list exists, there are a bunch of methods you can use with it. And you in Collab, you can see the list of methods by just typing dot, and you'll get autocomplete. And I'll point out, I guess, the most useful one. And append is a pretty useful one, and it it takes an object. And so I guess before that, let's see what is currently inside of this list A. So the list A has 4 elements correctly, 1, 2, 3, and 4. And if you want to add a new element to it, you can do it in a couple of ways. So yeah, the append method, so using the append method adds the new element to the end of the list. And you can also add two two lists. And when you add two lists, what's returned is the original list, and the new list, all the elements of the new list are at the end of the list. So um, if so if you assign the list plus a new list to the same list, in this case A gets replaced with the new list. And a shorthand for doing this operation is by using plus equals. And plus equals is just shorthand for A equals A plus. And by the way, this plus equals works with any type. So if we had if we had an integer and we wanted to add something to it, we can use plus equals. So here n plus equals 5 means replace n with n plus 5. So yeah, so back to lists. Another really cool and useful way uh, to create lists is something called a list comprehension. And uh, so let's start off with with a list with 5 elements, 1, 2, 3, 4, and 5. And what list comprehensions allow us to do is to create lists with statements in this with statements inside the definition. So for example, so what this particular list comprehension does is it creates a new list based on the elements of list A. And for each element in A, it puts that element plus 1. So an equivalent way of writing this list comprehension is start off with an empty list, and so this block of code is functionally equivalent to the previous list comprehension block of code. And yeah, and another thing is in Google Colab, when you hover over a variable, it shows what's inside of it currently. So I'll just be using that from now on uh, instead of printing it out in a new block. All right. So yeah, so as we can see, this is functionally equivalent to the previous one. And if we change this to +2, it becomes 3, 4, 5, 6, 7. And in a list comprehension, you can use conditionals too. So let me define a new list using a with a conditional too. So what this firstly, this percentage operation is called modulo, and it gives you the reminder when you divide the number with whatever you've provided next. And x percentage 2 equals 0 is shorthand for that number is even, because an even number when divided by 2 has no reminder. So this list comprehension gives you all of the elements which are even. And let's define a new list. So this list, in this list definition, I'm using this function called range. and range is a pretty useful function which creates a sequence of integers. And yeah, you can get, I guess, its entire details by hovering over it and looking at the documentation. But the simplest way to use it is to provide it with just one integer. And when you do that, it it gives you back all integers starting from 0 till the value which you have provided -1. So if, for example, range 10 returns 0 to 9. Another way to use range is to provide it with two arguments. And if you provide it with two arguments, it becomes start and stop. So if we use 10 and 20, it gives you a uh, list of numbers starting at 10 and ending at 20. And the stopping point is not inclusive, which means it's not going to be included in the list. And you can also use range in list comprehensions. So suppose we wanted all even numbers between 0 and 100. We can use this list comprehension. So this is pretty similar to the previous list comprehension which we wrote, but except that instead of building it out of the list A, we're building it out of range 100. And so this is giving us all the even numbers between 0 and 100. Okay. And we can also use comprehensions to build dictionaries too. And the way to do that is pretty similar to list comprehensions. So in a dictionary comprehension, we need to provide it with both the key and the value. And following that, you can have a statement uh, with a for loop and an if conditional too, if you wanted. Okay. Yeah, and so I'm gonna quickly address a question which was asked in the chat, which is why the list is including the initial value and not the final value. And uh, the the answer for that is it's just the definition. It's just a part of the specification for range. So yeah, so if you look at the documentation of range in Python, it says that uh, let me find that part. All right, so yeah, I brought up the documentation of list inside of this. And okay, in this, it says that start is inclusive and stop is exclusive. And inclusive means it's going to be included, and exclusive means it's going to be it's not going to be included. And so range doesn't include stop just because it's a part of the, it's a part of the definition of that function. All right, so and yeah, but I guess back to comprehensions. Comprehensions are really useful if you have a existing list or dictionary and you want to filter it in some way. So let's reuse a dictionary which we defined last time. Yeah, so this is the dictionary which we used last time. And let me show you another way to define dictionaries. Yeah, so similar to how you can define lists with some values already inside of them, you can do the same thing with dictionaries. And for that, you have to provide each element with key, colon, value, and they're separated by commas. And if we see what's inside of them, we can see that it has the 3 items which we specified. And if we wanted to create a new dictionary, which is based out of this dictionary, we can use comprehensions. So for example, if we wanted a dictionary with only the values greater than 50, we can use the a comprehension like this, which says that get all the name and score from this old dictionary called test scores and return it if the score is greater than 50. And this is functionally equivalent to the uh, to writing a for loop and creating a new dictionary. So yeah, any questions on list and dictionary comprehensions? All right, so yeah, there don't appear to be any questions. So now that we know some ways to create lists and dictionaries, let's revisit uh, the examples we worked through last time and try to have them return things instead of printing things. Okay, so let's say we needed to define a function which returns all of the students who passed, and a student has passed if their score is greater than 50. So in this case, what we want to do is uh, return a list of, let's change this to have it return a dictionary. So basically we want to return this. So I've defined this function which returns a dictionary, and this dictionary is constructed using the same comprehension which we used before. And let's try using this. So we can see that when we call this function with the dictionary which we defined earlier, it returns a new dictionary with a limited with a subset of uh, the elements in the original dictionary, and the original dictionary is not affected. So if we look at what's inside the original dictionary, it's still going to have all of them. And we can we can use this function in any place we would use a dictionary. So for example, if we wanted a list of the names of all of the past students, we can do it in multiple ways. So the first way is to just if we just create a list out of a dictionary, it's going to use all the keys. And if we use the values method, it's going to return all of the values. And we could also use the items method to have it return a list of tuples, which uh, I'm not sure if you have learned about tuples yet, but the short version is a tuple is pretty similar to a list, except that you can't add elements to it. So it's something like a read-only list. Anyways, so defining functions which return lists and dictionaries are useful ways to like to build some sort of a processing pipeline. So for example, uh, let's say we wanted to define a function which prints some sort of a summary based on a scores dictionary. So inside of this function, we can reuse functions which we've defined earlier. So in this function, we're getting one argument, and I'm using that argument inside this to get information from another function, which in this case is past students. And let's try running this against the dictionary which we already have. So yes, it's printing out past students and this new dictionary. And we also defined a print test average last time. And this function also was printing something instead of returning something, so it wasn't very useful. So let's change this to have it return the average instead of just printing it. And now we can use this function inside of another function. So so now this class summary builds of uh, these two functions which we've defined previously. And we can also use use functions to, I guess, combine things. And for example, what I mean by that is, for some reason, if we wanted the average score of only the students who passed the test, then we can combine these two functions, test average and pass students. So now we can, this, I'm calling test average with a function call inside of it. So the way to read this is, you need to replace what's inside of these brackets, which is past students test scores, with whatever it returns. So since past students test scores returns a dictionary, what would happen is, this new dictionary would be sent to the test average function instead of the original dictionary. So since we're only passing uh, a subset of the original dictionary, we can see that the average is different, it's higher. So the average score of all the students who have passed is 92.5, as opposed to the total average, which is 76. So now let's talk about some more useful things you can do with lists and dictionaries. And firstly, we've seen a few conditional operations so far. So we've seen the we've seen the greater than operation, which we've used with numbers, and the that that does exactly what it sounds like, which is it tells you if if the number on the left is greater than the number on the right. Similarly, we've seen the less than operation, which tells you the number on the left is less than the number on the right. And we've also seen the double equals operation, which tells you if two things are equal. So for lists and dictionaries, there are some more operations like this which we can perform. And a very useful one is called the in operator. And the in operator tells you if the thing on the left exists inside the thing on the right. So we can use this for different data types. So when you use it for a list, it tells you if the element uh, exists inside of the list, and in this case it does. And so 4 exists inside of this list, 1, 2, 3, 4, 5, which is why we're getting back true. And 10 does not exist uh, inside of this list 1, 2, 3, 4, 5. And we can also use it for dictionaries. And when you use it for dictionaries, it checks inside of the keys by default. So if we look at RAM in test scores, we get back true because a key called RAM exists inside of the test scores dictionary. And ABC inside of test scores returns false because there is no key called ABC. And it's really important to remember that for a dictionary, in checks uh, inside of the keys only. And I guess to drive that point home, if I try using so 45 in test scores returns false, and you might think that it should return true because there is actually a test score called 45. That's not the case because in looks at only the keys. If you wanted to see if there was a value called 45, you'd have to check inside of values. And you can also check if a key value pair exists inside of a dictionary using a comma, and then looking inside of items. So firstly, let's try looking if So now we're checking uh, if there is a key of RAM with score 90 instead of inside of test scores by using the items method, and we see that it's true. And if I change this to some score which is not what's actually inside of the dictionary, we get false instead. And we can use the in operation to construct new lists or dictionaries or filter them. So let's create a new example based on the whole test scores dictionary approach. So I've created two dictionaries. The first one is the same one which we've used before, and the second one is a new dictionary with different scores. And let's imagine that this means that the first dictionary math class is the scores of the students in math, and the same thing for English. And yeah, let's also create a new one. Okay, so we have three dictionaries now, and uh, let's try to use the in operation to, yes, let's put that to effect. So uh, okay, let me try to come up with an example. So suppose we wanted to uh, find the list of students who who failed in both math and science. So actually, yeah, let's reuse the past students function which we already had here. So the past students method returns all these students who have passed in that particular class. And if we run it with math class, we get back these two students. And if we run it with uh, So there was a mistake in this function. We were using test scores in this list comprehension instead of scores. So the value inside of the uh, from the argument was not actually propagating. So I'm fixing that by changing this to scores. And let's rerun this. And so, yeah, and we can see that with uh, with past students of science class, we get back these two students and their scores. So let's do an exercise now, and I want all of you to create a Google Colab worksheet and try to solve this in like maybe 5 or 10 minutes. And what we want is uh, we want to create a list of students who passed all classes. So and this function takes in 3 arguments, let's say. And it returns so so for example, if we call this with the 3 dictionaries which we've defined before, which students have passed all classes. So you can see that there's only one student who has passed all 3 classes. So when we call this new function with the 3 dictionaries which we've defined before, it would be it would return only it would return a list with only one name, which in this example would be yeah. So go ahead and spend about 5 to 10 minutes trying to fill in this function. If if you're stuck, it's probably better to start off with just 2 classes. So let's change this to take only 2 arguments. So yes, some hints if you're stuck. So the first thing to do is to, to understand the problem and try to break it down. And so this this particular problem says that we need to find the students who have passed in both of the classes. So the first part is kind of obvious, which is to get the students who have passed in each class, and we already have a function for that. So if we use the past class, the past students function, so we can see that past class one has, let me make this more clear. And I'm changing this argument to, so in the way I'm calling this is I'm setting the first argument as math class and the second argument as English class. So inside of the function, I'm using the previously defined past students function, which which just returns a dictionary. So the past students function returns a dictionary of all the students whose score is greater than 50. So the list of students who passed math class is Ram and Sita, and the list of students who passed English class is Ram and Champu. So that's the first part. And the second part is we need to find the elements which exist in both of these lists. And there's multiple ways to do this. Yes, let me create a couple of new lists to so the most uh, obvious way to do this would be to use a for loop. And we can start off uh, with either elements with either list. So for X in list one is going to go through every element of list one. And we what we want to know is if this element also exists inside of list two. And the way to do that is by using the in operator. So here we can see that it found the common elements. And how do we write this in a, I guess, in a easier to understand or a slightly cleaner way? We can do that using a list comprehension. So now I'm basically flattening this loop and using a list comprehension instead. So we're going through all the elements of list one and checking if that particular element is inside of list two. And this is pretty much exactly the same as this for loop, except that it's in one statement instead of multiple. Similarly, uh, we can also use not n, and not n is the opposite of n. So this list comprehension is a simple way of doing what is specified here. So for our students who pass both classes, we can just do that exact same thing. So let's return a list here. All right, so yeah, so here we see that we're returning just RAM, which is what we expected. And let's change this to, if we change this to science class, it returns two students instead of just one. And let's do one more exercise. So suppose we have a lot of classes, and we don't really uh, want to have each one of them inside of as a separate argument. So now we've defined a function which takes in one argument, and we're going to we're going to provide a list for that argument. So this particular function is taking in just one argument, and that argument is a list where each element is a dictionary. So this is a list of dictionaries as opposed to a list of numbers like we've done many times so far. So what we want to do uh, is to define a function which takes in a list of dictionaries and have it return the names of students who have passed all classes. And yeah, I want all of you to attempt this for about 10 minutes or so. And basically what we want to do is use this function which we've defined before, which works for two classes, and extend it to work for an arbitrary number of classes by using a for loop. Let's start working through this. So the first thing is obviously to uh, break down this problem again. So we want the students who passed all of these classes. So the first thing to do would be uh, to find out the students who passed in each class, and for that we can use a list comprehension. So uh, what I'm doing is I'm building a new list here, and for this new list I'm using a list comprehension, and each element is uh, is past students of class core. So I'm using the function which we've defined earlier uh, to get all the students who have passed this particular class. And in the for part of this list comprehension, I'm just going through every element inside of this list. So this gives me a list of lists, which and each one of them has the students who passed in that particular class. And so the second part is we need to find the elements which are common among all three of them. So yeah, let's put that in a separate function. So this list intersection function is supposed to take a list of lists and return all the elements which are common. So firstly, just I'm printing out the argument just so that we can see what it looks like. And we can see that it's a list containing lists. And what that means is that there can be a arbitrary number of elements inside of this argument. And so we already know how to solve it for two elements. So if we had just two lists, we would use this list comprehension: x for x in list one, if x in list two. But we need to find a way to combine it for an arbitrary number of elements. And how do we do that? All right, so we um, to make this simpler, to make this simpler, it's easier to build off of what we already know. So let's extract the first list and let's extract the second list out of it. And so what I've done here is I've gotten out the first list and I've gotten out the second list, and I've used the list comprehension from before. So far, our implementation of this function would only work for two lists. So if I added a new list with 3, 4, 100, 200, the function still works because I've not changed the specification of the arguments, but the thing it returns is wrong because we're not actually using the third list anymore. So how do we extend it for the third list? So let's say instead of printing it out, let's store the elements common between list one and list two inside of a variable. And if we need this to work for a third list, we basically need to do the same thing again. So what's happening here is we're doing this list comprehension twice. And the first time we're finding all the common elements between list one and list two. And then we're finding all the common elements between common and list three. So while this works, it's not feasible to keep doing this again and again for each new list we want. So what we actually want to do is somehow put this inside of inside of a for loop. So let's change this to a for loop. All right, so this is what we've reduced it to by changing it to a for loop. And how this works is, firstly, we're creating a new list called common, which has all of the elements from the first list. So to start off with, the list common has all the elements of list one. And then we're doing a for loop, but we're doing something slightly different inside of this for loop. Instead of for list in lists, we're adding this one here. And what this means is that instead of starting at the beginning of the list, we're starting at the second element by using one here. So during this for loop, it's going through all the elements starting from the second one. So the second list was list two, and so it's finding the intersection of common, which we initialized with list zero, and it's intersecting it the with the list 3, 4, 5, 6, 7. And after we do this, let's print out common again. After we do this, we can see that common now has only 3, 4, and 5. So uh, we're basically reduced it from 1, 2, 3, 4, 5 to 3, 4, 5. And then we're going to go through the for loop again and repeat the same operation the with the next one, with the next list. And so as it goes through the whole for loop, in the end, we see that there's only one element left. And for our exercise, the way to do this would just use the function. So our function returns a list, and let's just print out what it returned here. And yeah, let me comment out the print statements we put there for debugging. So yeah, so now when we call this function, we're first creating a list of lists using the past students function, and then we're sending this new list of lists to the to the list intersection function. And so we've combined the two separate functions which we have to inside of this new function, which basically extends it to work for this particular use case. So this list intersection function could be used for any types of lists, and it's not really specific to this whole class and test course problem. And so it's general enough, but it can be used for this particular use case and uh, also for other use cases. And in the real world, there's a better way to do something like this. Like there's a data structure called set, which is similar to a list but doesn't allow duplicates. And yeah, I encourage all of you to take a look at the documentation of sets to see the features they offer. And uh, in short, sets are defined very close to dictionaries, but instead of a key and a value, you just specify a key. And sets have an intersection method inbuilt, and sets do not allow duplicates. So if I try to add an element which already existed inside of a set, if I try to add an element which already existed inside of a set, nothing would happen because that element already exists. Very similar to how in a dictionary you can't have the same key twice. But in a list, we can have the same element multiple times. And yeah, we'll talk about sets a little bit more in the next worksheet on Wednesday. But before that, I'd encourage all of you to just take a look at the Python documentation for lists, sets, and dictionaries. So basically, in the link is in the chat, and this goes over the important operations for the main data structures in Python. And you don't need to read the whole thing. You just need to take a look at like the beginning, which which describes the data structure, and the examples which are in green. And this will give you a very good overview of the useful methods for the data structures. And yeah, we'll try to build something a little bit more complex and closer to real world data analysis in the next worksheet. All right, thanks everyone.